Hey, in this tutorial we're looking at section 6.3 on incline planes and connected particles. Okay, so for those students that have done some physics, okay, then part of this is definitely going to be stuff you've seen before. Okay, so start off with, we need action and reaction. So Newton's third law states that for every action there is an equal and opposite reaction. So the reaction force of objects sitting on surfaces is called the normal force and is denoted by N. I know that's a little bit annoying at times because we use N for our symbol for our newtons as well. It's actually for our force, our normal force. So the normal force always acts at right angles to the surface and has a magnitude equal to the weight force acting in the same line as the weight force. Okay, so we always act, particularly when we're on flat surfaces. Okay, it's easy because we can just say, well, here's our normal force N, and here's our weight force. Okay, and then going to be equal and opposite. Okay, however, when we get to inclined planes, there's not quite the same. So smooth plane means that there are no frictional forces. The normal force, okay, is equal to mg cos of theta. So it's the part of our weight force that acts in the same line, okay, to our normal force. Okay, so we're going to have our mg cos theta, okay, and then we've got mg sin theta, okay, acts parallel to our plane. Okay, and causes the object to accelerate down the slope, or want to accelerate down the slope. Now remember, m is our mass, okay, and g is our gravitational field strength, or our acceleration due to gravity. So m is mass, okay, and g equals our 9.8 meters per second squared. Okay, so we'll keep moving on. Okay, so we're looking now at worked example 8. Okay, so we've got a suitcase of mass 12 kilograms is maintained in equilibrium on a smooth plane inclined at 60 degrees to the horizontal by means of a strap. Find the tension in the strap and the reaction of the plane if the strap is parallel and acting up the line of the greatest slope. So we need to draw a picture to start off with, so we've got our head around what's actually going on. Okay, so we've got our slope. We know that that's 60 degrees. Okay, we've got our object here, which in this case, like I said, is a suitcase. Okay, and we know the mass of that is 12 kilograms. Okay, so we're going to have our normal force acting out this way. Okay, we've got our weight force acting this way, which is going to be equal to 12g, or 12 times our acceleration due to gravity. And what we're saying is we also have a tension force this way, okay, that's acting parallel to our surface. Okay, so what we need to do is we need to set up our triangle here. Okay, and we know that this angle here, okay, is going to be the same as our angle here. So that's one of the benefits, is that when we set up this up, we've got a right angle here. Okay, that angle is going to be the same as this one, so that's going to be 60. Okay, and this bit's going to be 12g cos of 60. That's this bit here. And here is 12g sine of 60. Okay, so we know that our force needs to be, that our object is in equilibrium. So that means that this force acting down the slope has to be balanced by a tension force. So basically we can say our tension force minus 12g sine of 60 has to equal 0. So our tension force has to equal 12g sine of 60, which is 12 times 9.8 times sine of 60. Okay, which is going to equal then, for some reason they don't actually put in the 9.8, I'm not sure why. Let me just see if we, no, for some reason they just leave it in terms of G, which seems bizarre, but anyway, so sorry, we'll ignore this line. Okay, and so our tension, okay, is equal to 12g sine of 60 is root 3 on 2. Okay, so we get 6 root 3 g newtons for our tension. Okay, and we also need to find the reaction force, which is this bit here. Okay, so our N value is just going to simply be equal to our 12G cos of 60. Okay, cos of 60 is a half, so we have 12G times a half, so we're going to get 6G newtons. Okay, I would never leave your answer in terms of G. Okay, you should be multiplying it by your 9.8. Okay, I'm not sure why they didn't in that worked example. That seems a bit bizarre. Okay, so we need to resolve all our forces. When two or more forces act, it is easy to forget to resolve all the forces into their components. So we need to make sure, okay, that when we've got two or more forces, okay, that we resolve all of them. Okay, so now we're looking at the same idea with our suitcase. Okay, here we've got our plane at 60 degrees. We've got our 12 kilogram suitcase. Okay, but this time our tension force doesn't act parallel to the plane. Okay, actually makes an angle of 15 degrees. Okay, and we're going to have our normal force, and we're still going to have our 12G force down this way, which means we're still going to have everything that we had just a minute ago. Okay, we're going to have our 12G cos of 60. Okay, because remember this part here is 60. Okay, and this is going to be 12G sine of 60. Okay, that part there. Okay, and this is our tension force. Okay, so we need to find the tension in the strap. Okay, so we need to do a similar thing up here and resolve it, our tension force, okay, into a part that goes this way. Okay, which is going to be T sine of 15. Okay, and this part down here, okay, is going to be T cos of 15. Okay, so that's this part. The part that's parallel is our T cos of 15. Our part that's perpendicular is T sine of 15. Okay, so we need to resolve all the forces up the plane. Okay, so we're going to have our T cos of 15. Okay, take our 12G sine of 60 equaling 0. Okay, so that's going to be equation 1. Okay, our normal force, well, we've got our normal plus this little T sine 15. So you can't forget that because that's acting this way as well. Okay, at right angles to our plane. So we also need our T sine of 15 this time. Okay, minus our 12G cos of 60 also equals 0. And that's equation 2. Okay, so from our first equation, okay, we can start to rearrange this, okay, and say, well, T is going to equal our 12G sine of 60 divided by our cos of 15. Okay, so that means this time, okay, in this example, they do put G in as 9.8, so T is going to equal 105.44 newtons. Okay, so now we can work out what our normal force would have to be because we know what T is. So we know our normal force, come up here, has to equal our 12G cos of 60 minus T sine of 15. Okay, and we know that we're 12G times a half, minus 105.44 times sine of 15. Okay, when we sub in G and we work all this out, we find that the normal force N is equal to 31.51 newtons this time. Okay, so we'll keep moving on. So we don't have too much more to go, but we now need to talk about connected particles. Okay, when dealing with connected particles or a system involving two or more particles, okay, we need to resolve around each particle independently. Okay, so we're going to have a look at worked example 10. Okay, so we have a mass of 10 kilograms lies at rest on a smooth plane inclined at 30 degrees to the horizontal. Okay, the mass is held in place by a string that is parallel to the plane and passes over a smooth pulley at the top of the plane. Okay, the other end of the string is connected to a mass m kilograms that hangs vertically. Find the value of m. So we need to set up our picture here. Okay, so we have a mass here. We know that's 10 kilograms. We know that our plane is at 30 degrees. So we know we're going to have a 10G force down. We know we're going to have a normal force that way. We've got a pulley up here. Okay, and our string comes up this way. And it comes down. And it's connected to some other mass M. So that mass M, okay, is going to provide our tension force, keeping our system in equilibrium. Okay, so if we have a look at resolving this here, okay, we're going to have a weight force of mg down, and we're going to have a tension force up. So we know our tension force minus our weight force is going to equal 0. Okay, and then if we have a look here, okay, if we set up this part, okay, we know that's 30 degrees again. Okay, and we're looking at this side, okay, in here, that's going to be 10G sine of 30 degrees. Okay, so we also know that our tension force minus our 10G sine of 30 has to equal 0, because we're going to have our same tension force, T, up here. Okay, so this provides our tension force. It also acts here. Okay, so we're getting there now. So we can really say that rearranging for T for both of these, okay, means, well, T is going to equal mg, so we can simply say that our mg minus 10g sine of 30 equals 0. So mg equals 10g sine of 30. Okay, so m equals 10 sine of 30, because we'll divide by g and they'll cancel out. Okay, so that means our m equals 10 times a half, so it has to equal 5 kilograms. Okay, so we isolate our system by just looking at our mass here first. Okay, and then that gave us our tension force, okay, that we needed to keep our package here in equilibrium. So I'll have a look at worked example 11. Okay, so what I'm going to do is I'll actually draw the diagram first, I reckon, and then we'll talk about what we have. So we've got a horizontal plane here, because it does look a little bit complicated. Okay, when we come down here too, down here, so we've got point P up here and a point S here. Okay, we've got a string coming down. Okay, that makes an angle of 70 degrees, and so this side is 20 degrees. Okay, and that's going to be onto a mass, okay, of 10 kilograms. Okay, so we're going to have this come down as a force 10G. Okay, we also have another string coming across to a mass of M, and that gets connected up to this side. Okay, so this is going to give us a force of mg down. We also know in here is a 10 degree angle, okay, which means that's also a 10 degree angle. Okay, and then our angle in here is 50 degrees. Okay, and we're saying that this is at point R and this is at point Q. Okay, so it doesn't look very good, but I'll read through the information they give us. So he's saying PQRS is a rope fastened to a horizontal beam at PS. So that's horizontal beam there. A mass of M kilograms is suspended from R. Okay, and a mass of 10 kilograms. Okay, so M kilograms and 10 kilograms is suspended from point Q. The section of rope PQ makes an angle of 70 degrees with PS. Got that. The section QR, is inclined at 10 degrees below the horizontal, while section RS is inclined at an angle of 40 degrees. 40 degrees up there. Okay, to the vertical. Find the tensions in all the sections of the rope and the value of M. So we need here, we need T1, here T2, here T3, and we want the mass M. Okay, so we've got our picture drawn up, okay, which is a good start. Okay, so there's going to be a fair bit to do here, okay, because as you'd expect, this looks like a pretty complicated example, so that we are expecting a bit of work here. So we want to resolve around our point Q here. Okay, and so we get T2 when we look at our force here. Okay, well we know our T2 cos of our 10 degrees, okay, minus, so 10 degrees, minus T1 sine of 20 degrees, okay, equals 0. Okay, so we're looking at the component here of this force, right, or our T1 force, okay, being in that direction. Okay, and we're saying that part and our horizontal part here, okay, they have to cancel out. Okay, now we need to look at our vertical part of this force. Okay, so we're going to have T1 cos of 20 degrees, okay, minus T2 sine of 10 degrees, okay, minus our 10G equaling 0, because we've got our vertical component from this, a vertical component from that, and this vertical component, well, they're all going to cancel each other out. Okay, so that's going to be equation 1. This is equation 2. Okay, now we need to resolve around R. Okay, so we've got to do our horizontal first. So we're saying we've got our T3 cos of 50, okay, minus T2 cos of 10. Okay, well that's got to equal 0, and that's going to be equation 3. Okay, now we need to do vertically around this one. So we're going to be saying T3 sine of 50 plus T2 sine of 10. Take away our mg, one going down, and that's going to equal 0. That's going to be equation 4. Okay, so there's a fair bit of work to do here. Okay, so we're going to use equation 1 to express T2 in terms of T1. So when we rearrange this, okay, we're going to get T2 equals T2, sorry, looking at the wrong line, is T1 sine of our 20 degrees over cos of 10 degrees. Okay, so that's just rearranging this first equation, okay, for T2. Okay, so we're going to now substitute, so if you like we can call this equation 1 again. Okay, we're going to sub this equation 1 into equation 2 for T2. Okay. Yep, and so we're going to, and then we're going to rearrange that as well. Okay, so we're going to say then that our T1 cos of 20, okay, minus T2 sine of 10 equals our mg. Okay, and well, we can bring out all our some of the other stuff across here. Okay, and say that we've got, well, we can put this in for our T2 now and say then that we've got T1 cos of 20 minus T1 sine of 20 times sine of 10 over our cos of 10 equaling our 10g. Sorry, that should be now 10g, no, our mg, 10g. Okay, so what we're going to do then is we can solve for T1 by taking our common denominator. Okay, so we can get these together by going, okay, well, we'll make it T1 cos of 20 cos of 10 minus T1 sine of 20 sine of 10 all over now our cos of 10. Okay, so that was multiplying this by cos of 10 so that we could add them together. Okay, so getting there. Okay, so now we could take T1 out as a common factor. Okay. Okay, so, and then, oh yeah, so I'm going to bring T1 out. Go, well, now we've got cos of 20, cos of 10, take sine of 20, sine of 10 over cos of 10 equaling 10g. So when we do that, okay, what we can do is use our compound angle formula. So that means that all of this is going to give us T1 cos of 30. Okay, and we can times across our cos of 10 to give us 10g cos of 10. Okay, so then we can go, well, T1 equals our 10g cos of 10 over our cos of 30. So T1 will equal 111.44 newtons, sorry. So we've got our T1. So I know it took an awful lot to get there. Okay, so we can substitute back in our T1 into our T2, okay, to get T2 equaling T1, well that's 111.44 times sine of 20 over cos of 10. So that means our T2 is going to equal 38.70 newtons. Okay, so now we can use these to solve for T3. Okay, because now we need T2 so we could get T3. So we can say, well, T3 cos of 50 take 38.7 cos of 10 equals 0. Okay, so we can say, well, our T3 equals our 38.7 cos of 10 over our cos of 50, and that gives us a T3 value of 59.30 newtons. Okay, and now that we've got that, we can solve our equation here for our m. Okay, I might just change textures here because I have to do it over the side. Okay, so we know that mg is going to equal our T3 sine of 50, okay, plus our T2 sine of 10. Okay, so we know our mg is going to equal our T3, which is our 59.30 sine at 50, plus our T2, which is our 38.70 sine of 10. Okay, and we can divide that by our g value as well. So we know mg, well, that equals, all this side equals 52.147. So m equals 52.147 divided by our value of g, which is 9.8. So m equals 5.32 kilograms. Okay, so there's an awful lot to do in this question. Okay, so basically we need to use equation 1 and equation 2 to solve for T1 and T2, then use T2 to find T3, then use T3 and T2 to find our value of m. Okay, so a fair bit in that. Okay, so again, these questions are awfully important for exams and SACs. Okay, so make sure you have quite a good understanding of how they work.